So we've been talking about confidence intervals, and we talked about point estimates being part of this confidence interval. So here is a confidence interval for the proportion sample for the true population proportion. So remember that this whole interval is for the true proportion, not for the sample. It's for the true proportion because that's what we want to figure out. We want to know more about the population. And this sample is telling us a little bit more about the population. So this p hat is basically our point estimate. Okay, so we're using a point estimate to try to figure out the truth. And now this guy right over here, this z star with the standard deviation and standard error, is what we call the margin of error. So if you want to think about it this way, when we find our confidence interval, we basically have our point estimate plus or minus the margin of error. Okay, so how far we are from our error, because you basically have some sort of error. So this basically, if you want to write it down in words, so this indicates the accuracy with which a sample population or some proportion estimates the unknown population proportion at the specified confidence level. Okay, so this margin of error basically indicates the accuracy with which a sample proportion estimates the unknown population proportion at the specified confidence level. So if I give you 95% and I'm using the sample proportion to kind of estimate this, well, this margin of error just basically is giving me some sort of bounds, an upper bound and a lower bound. Now, does it mean that I for sure will have that number? Or the true value in there? No, because remember that when we're constructing it, we are basically 95% confident that it'll lie between here and here. So we still can have some error, okay? So one of the things that is very useful to kind of figure out is like try to make our interval a little bit lower. So there's a couple things that we can do. So how can we try to minimize this error? So one way that we can do is try to determine the sample size. Determining sample size. And basically what this is really talking about is that if I increase my sample size, this is going to be decreasing the width of the confidence interval. And this makes sense because if I get more and more samples, well, that's making my estimate a lot bigger or a lot better, which actually is decreasing the width. So if I look kind of like at my confidence interval, if it's between that and I get more and more samples, then what's happening is that I'm getting closer and closer to the true value. So this is decreasing the width. Okay, so it's getting lower and lower and lower. Okay, so another way that you can kind of decrease the width of the confidence level is just by increasing the confidence level itself. So if I want to decrease the width of the confidence interval, I can no, not decrease. I can decrease my confidence level. So if I decrease my confidence level, I also decrease the width. That doesn't quite make sense because if I decrease my confidence level, I don't want to decrease my confidence and decrease my width because that's just silly. You know, I want to make sure that I have a really strong confidence and I have a really low width. So basically, the goal here is to have strong confidence and small width. Okay, so that's basically what I really want. And one way that I can accomplish that is by increasing the number of samples. So one way that we can try to do it is by trying to figure out what basically what how many samples should I get if I want to make the width small enough. So one way that we can do it is we know that the margin of error is given to us like this. So margin of error, let me just go ahead and give you a formula. So margin of error we're just gonna call it E for error. It's gonna be this Z star square root of P hat 1 minus P hat over N. So basically, this is just coming from the fact that if I look at my confidence interval, this guy is just my margin of error. So I'm just saying this equal to E, okay? And then basically what I'm going to do is that I want to solve for N. With a little bit of algebra, you can try to figure out that N is going to be equal to P hat 1 minus P hat, and then Z star over E squared. You don't need to really know the algebra behind it, but just know this formula. This formula will be given to you on the exam, so you will have that, okay? Okay, and the whole point is that we want to be able to figure out N, okay? So, if you don't know if N is unknown, right? Because in this case, we don't know what N is, then P hat is unknown as well. Which that's a problem, right? Because if I want to figure out, okay, how many samples should I get if I want to be, if I want my width to be a certain amount? Well, if I don't know what N is, well, I definitely don't know what P hat is, okay? So what can we use? Well, there's a couple things that we can do, okay? So one thing that you can do is use P hat equal 0.5. This is what I would consider to be the best estimate. So just kind of estimating it. Just thinking, oh, I think it's just going to be 50-50. Let's just go ahead and say that that's what's going to be. If you don't feel comfortable using p hat, usually what you can do is you can use some guess. Make a guess. Now you physically won't make a guess. I will have to tell you what the guess is. So this will be given to you from the instructor. Okay, but in practice, you might want to make a guess of what you think it probably will be. Okay. All right, so let me give you an example. Okay, so consider estimating the proportion of employees who call off work. Okay, so part A says, what sample size will ensure a margin of error of at most 0.01 for a 95% confidence. Okay, so suppose that we are estimating the proportion of employees who call off work. Okay, so the true value, we want to figure out what that is. So we want to know, okay, so what sample size? So how many people should I sample? Okay, so that my error is by maximum 0.01 and I want to be 95% confident. Okay. Well, first let's start off by writing down the formula because here we want to figure out the sample size. So what's sample size? Well, remember here, N here is the sample size. So let's write down this formula. So N equals P hat 1 minus P hat Z star over E squared. Okay, so notice here we are not given P hat. So what we're going to use is we're going to use the best estimate, which is going to be 0.5. So I'm going to plug in 0.5 into P hat. Okay. Now, what is Z star? Well, if we want a 95% confidence, well, Z star is just going to be 1.96 squared. And then E is going to be my error. Well, I want my error to be at most 0.01. Okay. So now what I'm going to do is I'm going to put this into my calculator. Okay, so 0.5 times 1 minus 0.5 times 1.96 over 0.01, and I'm going to square the whole thing. And that's going to give me exactly 9604. Okay. So again, just basically plugging it into the formula, not a lot of things going on here. Okay, and now let's do this part B. Suppose you guess that about, I don't know, 40% of employees call off work. Find the required sample size using the same information from part A. Okay, so now we have some sort of like some guess. So I'm guessing that about 40% of employees call off work. So what would be the required sample size using the same information from part A? Okay, so that means that I still want it to be at most 0.01 and I still want to be 95% confident. So let's go ahead and use it, plug it into the formula. N is equal to p hat 1 minus p hat z star over e squared. So now p hat is not going to be 0.5. Now it's going to be this 0.4 because now we want to ensure we kind of have a guess. It's going to be 0.4, 1 minus 0.4. Then this hasn't changed. It's still 1.96. E is still going to be 0.01 squared. Notice that if I were to change it to a 90% confidence, then it would be something completely different. Same thing if I change it to a 99% confidence. Okay, so what is this going to be? So I'm going to put 0.4, 1 minus 0.4, and then I'm going to have 1.96 divided by 0.01, and I'm going to square this whole thing. And what I end up getting is 9219.84. Now, because we're talking about samples, you always want to round up. So even if you have a decimal here, you always round up. So in this case, this is going to be 9,220, okay? So I need about 9,220 samples in order for me to be 0.1 at most of margin of error with 95% confidence. So you can see that these guys are a lot of samples, okay? We need to get a lot of them to make sure that we are off by a little bit, by 0.01, okay? One more thing about rounding up. Let's say you ended up getting something like this. Okay. I know that usually if we were to round it would be 938, but because we're talking about samples, this 0.1 is going to bring it up. So this guy is going to be 939. So we're always rounding up regardless of what the decimal is. This is only for this particular unit, not for anything else, just for required sample size.